Welcome to this open security training course about intermediate TPM usage. This is the second course in the series, TC1102. And if you haven't taken the first course or don't know what the TPM is, haven't used it before, please make sure to go through the first course and then come back here. Now, for those of you who already know what TC1101 is, some of the things we say now may feel a bit familiar, but we will try to build on that as we make an introduction toward intermediate TPM usage. For example, one thing remains constant in these courses. Our goal is to have practical exercises and practical skills gained throughout the course. Few words about myself. I'm the founder of the largest developers community about hardware security called TPM.dev. We have over 600 members. Some are long-time professionals, others newcomers and enthusiasts. The same way, this course will help anyone wanting to get into the field or extend their existing knowledge and upskill what they can do with a TPM. My background is industrial automation. I have designed and developed a lot of Internet of Things devices, industrial systems, metering, control, and so on, including some medical devices. But enough about me. Let's get going. Naturally, we have to do a slight recap of what we covered in the first course, TC1101. And I think the most fundamental part of that course was the understanding that security based only on software can no longer provide us the guarantees that we need to have security and trust in our systems. This is where the Trusted Platform Modules, TPM, come into play. They serve as a hardware root of trust. We generate our cryptographic keys on the TPMs. We use the TPMs to generate digital signatures. In this course, we will also learn how to generate evidence about the state of our system. Other interesting use cases we covered in the first course was the creation of TPM key that can store arbitrary user secret in it. And there was a limitation up to 128 bytes. Of course, we also covered how we can use the TPM to perform encryption. And because the key can only be loaded and used by the TPM to perform the cryptographic operation, we have high guarantees about the protected data. We also learned that TPM child keys can be stored outside the TPM because they come in encrypted block form that only the TPM and the owner of the primary key under which these child keys are can unwrap them and load them. We learned a lot about the non-volatile memory of the TPM because this is one of its unique properties, that it has this secure storage, physical secure storage, available also to the user of the system or to the owner or to the administrator, depending on your use case. And we learned how to store different data there, how to create NV indices and make use of them. And this can be combined with enhanced authorization, something we'll cover in this course. We'll learn about TPM 2.0 policy, but let's not get ahead of us. Let's go on the next slide and learn more about what's coming in this course. The course structure of TC1102 is similar to TC1101, and this is by intention. We want the course to feel familiar and yet introduce a lot of new things. I think the most important improvement from the course structure perspective was the addition of a glossary, sort of a dictionary that we can look up important terminology or specific terminology that is related to trusted computing. This came as feedback from students during the beta course of TC1101. And again, I want to thank everyone who participated in that because it helped us make the course better. So in TC1102, we'll have the glossary from the start. And again, we'll base it on the official TCG documents, that is the TCG glossary, and you have a direct link to that if you want to start reading ahead. Then we have the introductory topics. This lecture is part of that. We'll also have the setup of our lab environment, and this is exactly the same as in the first course. Again, by intention. We have a web environment. You can run it locally using Docker, or if you prefer, of course, you can use a hardware TPM and work directly. Just be aware of the risks. But more on that in the next lecture. Now, to complete the introductory topics, we'll take a quick lecture about ESAPI, the Enhanced System API. Because in this course, we will develop our TPM applications. In the previous course, we had only a glimpse of that at the end, and we use mostly TPM2 tools. Here, we will primarily use the TPM2 TSS and its ESAPI, Enhanced System API. Of course, every lecture comes with its labs, and as you go throughout the course, you'll see there will be a lot of labs, similar to TC1101. Maybe one of the most important questions for this lecture: what will we learn this time? A lot of things. So I had to pick some highlights, maybe my favorites. I think with the rise of connected devices throughout our home, throughout the industry, throughout our streets, in the cities, and in the cars nowadays, we need to talk about machine identity and how the TPM is a great tool to achieve that. We need to talk about TPM verification, how to prove that the TPM we have on the system is genuine. It has been manufactured and provided by the vendor, by the TPM vendor who produced it. And through there, establish a root of trust that will allow us to build machine identity that is unique to the system having that TPM. From there, we'll move on to create attestation and file system integrity. This is just the start of building system integrity as a whole, essentially getting into the concept of trustworthiness and trustworthy computing and trustworthy systems. You've heard a lot about confidential computing, which has protection of the data in use. Well, everything starts from the system integrity, from the measured boot, from measuring the files that we launch, from the operating system that we load, from the drivers, and so on and so on. So we'll talk about platform configuration registers, a topic that was in high demand during TC1101, but we had to have it now. We had to skip it in the first course because there was so much practice and knowledge that we had to gain. If you already had that knowledge, then this is the course you've been waiting for. And last but not least, we will start learning about TPM 2.0 policy, and we will learn about specific policy usage. And this will be just the beginning. Be aware, the enhanced TPM authorization is complex. It has many policy commands. So we will start to unwrap that. And hopefully we will talk more in detail about policy in the TC1103. But here we will lay the foundations and we'll start using TPM 2.0 policy. Our lab setup, as mentioned earlier, is quite straightforward, and this is by intention. Same time as before, we'll have the IBM TPM simulator by King Goldman. We'll have the TPM2 TSS stack. We'll have the TPM2 tools just in case. In some scenarios, we'll use them just to demonstrate something, and then we'll go do it using the TPM2 TSS and our own TPM application written in C code. So of course, to make things easier, we provide a ready-to-use Docker image with everything bundled, and you can just get going and do the labs after the lectures. Of course, there is lecture B to help you, guide you through the use of the lab setup, and I hope that's easy. If you have any questions, do not hesitate to reach out and ask. In general, our experience from TC1101 has been that the Docker container is really easy to use and has everything that you need. Some of the highlights of our exercises in this course are on your screen right now, and I will not just read it. The essence of it is we will build up your skill as an engineer or as a security practitioner or as a student and enthusiast from machine identity toward remote enrollment using the TPM of your device. Is it industrial system? Is it your IoT project? And then learn about the PCRs, learn about attestation, and complete the whole path from start to end. So you have all the tools, knowledge, and practical know-how to achieve from start to end enrollment, establishing machine identity, ensuring system integrity, and thus building trust in your systems. This is the reason we built this course, to give you these practical skill about intermediate TPM usage. And of course, there's more. We will cover policy, PCR policy specifically, again, to tie it to the attestation topic, to tie it to the PCRs and the system integrity and the protections. I already gave a glimpse of why machine identity is so useful, but we need to tie it to the TPM properties. As you well know from the first course or from your prior knowledge, we have several hierarchies in the TPM. We have the endorsement hierarchy, which we haven't spoken a lot in the first course on purpose. Now it's when we cover it. Then we have the owner hierarchy, which we used a lot in the first course, and this is typically what you use throughout the lifecycle of a device, throughout your application. But in some cases, like with machine identity, the endorsement hierarchy provides us a bind, a link from the TPM to the vendor, thus establishing trust. And from there, we have something called endorsement key. This is a key that lives under the endorsement hierarchy, and because they are templates provided by the TCG, we can have a reproducible machine identity following those templates. Of course, we select the template that we like, and we'll talk about that in a lecture. And through there, from the endorsement hierarchy, through the endorsement key, we have a link to uniqueness to the vendor. From this comes the next thing. Okay, we need some way to attest that, to verify, to walk this chain of trust. And this is where endorsement certificates came into play. We will cover details in a dedicated lecture. I just wanted to introduce the idea of the endorsement hierarchy has some special properties that we'll talk more about later. And because of these properties and because what the TCG provides as templates, we are able to establish a reproducible link between what our system is and has and the origin of the TPM. And from there, enroll a system remotely and start building trust with attestation and so on. And of course, we wouldn't be able to do that without a mechanism built in the TPM called Platform Configuration Register. In essence, the PCR is just a register memory that can hold the size hash digest. And while it sounds simple, there is more. There are special properties of the PCR. Most notably, when can we reset the PCR? When can we set it to 0 or to all once? Well, this is defined by the TPM and the TPM spec. In most cases, this can happen only during power on, essentially system reset, actual power on off, in most cases. And this makes the PCR special. This means that the information that we extend, we put into the PCR cannot be tampered with because the system has to be restarted physically, power on off, which is great. Okay, so then also another property of the PCR is that we preserve the old value and we concatenate the new hash digest, which results in another value, another digest that has been result from the old state and the new state that we introduced. This is especially useful when we do measure boot and we measure all the stages of the operating system or the firmware that we're loading, and we inherit the information from before. So as long as we follow the same steps and it is the same system, we'll get the same result, the same digest at the end. And this cannot be reset until the system is power on, power off. So that's great. And of course, this mechanism of security about when can you reset it is tied to another property of the TPM called locality, and we'll talk more about that in the dedicated lecture. Here I'm just outlining what's in store for us in this course. We'll talk about attestation in general, how it works, why it's valuable, and what are the common pitfalls. And then we'll focus on file attestation. File attestation is the generation of a hash digest over a file, and then putting that digest into a PCR. This is valuable because we know the PCR cannot be tampered with. It also inherits the previous state. The old hash digest impacts what is the end value of this operation that we call PCR extend. And from there, we can then sign that digest using the TPM and create a report. And that report happens inside the TPM with a key that is again bound to the TPM, and also we can link it to the identity of the TPM that we mentioned earlier, that we can create a machine identity. Of course, there are other types. There's key attestation, there's time attestation, and there can be many more types based on the type of data or interaction that you want to attest, you want to generate evidence about. Typically, file attestation is quite universal, because if you think about it in Linux, everything is a stream. If everything is a stream, it can be turned into a file, and from there you have it. Using file attestation, you can verify a lot of things on your system, almost everything. Now, I am pretty sure that for some of you, this could be an overwhelming amount of information, but remember, this is just the introduction. This is just marking the topics that we'll cover in more detail. And we have tried to separate things and topics moving forward, so it is easier for you to focus on a certain topic, on a certain exercise, specific use case. So don't be scared, just go through the next lecture, go through the first labs. If you have questions, ask in the forum, ask on Slack on tpm.dev, in the TPM2 TSS mailing list. There are many options out there for help, and we are here also to help as much as we can.